Hello, this is 10.2 Hyperbolas Part 2. And I want to talk really quickly about the definition of a hyperbola. So the hyperbola, if you take the distance from one focus to any point on the hyperbola and the distance from the other focus to the same point on the hyperbola, if you subtract those two distances, you will get the same number every time. So it's the set of points such that the distance from one focus minus the distance from the other focus is a constant. Okay, so that is the definition, and the book uses that definition to get the equation. I'm not going to go through that. If you're interested, you can do that on your own. Okay, so I want to talk about the equation. So I'm actually going to scroll down to equation not centered because I think that's more interesting. It's the more general equation. Not centered on the origin. So just like when we had, just like with ellipses and circles, this is going to be the x coordinate of your center. This is going to be the y coordinate of your center. Unlike ellipses, A does not have to be your biggest number. So with ellipses, we always knew that A was the half the length. A was half the length of the major axis, or specifically the distance from the center to a vertex. It's still going to be the distance from the center to the vertex, but it doesn't have to be bigger than B. Because unlike with an ellipse where the major axis was always bigger than the minor axis, the transverse axis does not have to be bigger than the conjugate axis. So A is going to be half the length of the transverse axis, or in other words, the distance from the center to a vertex. And B is going to be half the length of the conjugate axis, or the distance from the center to a co-vertex. And that's always going to be true, but A doesn't have to be bigger this time. You can also see that we can have a situation where X is the front term, or we can have a situation where Y is the front term. Whichever one is the front term, that is going to tell you the direction of your hyperbola. So if X is the front term, then your hyperbola is going to be opening up right and left. And so I'll just go down here. If X is your front term, your hyperbola is going to be opening up right and left. If Y is your front term, then your hyperbola is going to be opening up and down. So that's the difference between these two. This is a right to left hyperbola. This is an up and down hyperbola. But notice A is always under the front term because A is going to be the distance from the center to a vertex, center to a vertex. It could be right and left, it could be up and down, but it's always the distance from the center to a vertex. So this is A, this is B. And then C is going to be the distance from the center to the focus, center to the focus. Okay. So those are the pieces of your equation. Let's talk about how we find C. They have the equation here, right here. Basically, it's another Pythagorean relationship. It turns out that this distance here is C. So this distance is C. So this would be my right triangle. So this times C is the hypotenuse. So in an ellipse, it was C squared equals A squared minus B squared because A was the hypotenuse. Now C is the hypotenuse. So it's C squared equals A squared plus B squared. So that's the difference here. C squared is now the longest one. C, I should say, is now the longest one, which makes sense, right? Because C is on the outside. Whereas in an ellipse, the foci were on the inside of the ellipse, right? In a hyperbola, the foci are on the outside of the hyperbola. So it makes sense that C would be the longest distance. Okay. The last thing I want to talk about on this is the equations of the asymptotes. Sorry, words just went out of my brain. Okay, the equations of the asymptotes. So it's going to be, it's always going to be plus or minus. So notice this y equals plus or minus, because we're going to have one positive slope and one negative slope. And what we're going to do is we're going to define it using point slope format. So if you remember from way back in like algebra 1, we did point slope format where you had the you put in a point, and so technically point slope format would have been y minus k on this side equals the slope times x minus h on this side. But we're moving the k over to the other side just so that it looks like a normal linear equation. So we've moved k to the other side. So we're going to have plus or minus, because remember this is two asymptotes, and one of them is going to be positive and one of them is going to be negative. And the point that we're going to use is the one point that they will always share, and that's the center. So that's why it's h and k, because these two asymptotes on any hyperbola will always go through the center, which means that is the one point that they all share. So we're using that. And the slope for a horizontal hyperbola, the slope is going to be plus or minus b over a, right? Rise over run, b over a. For a vertical hyperbola, it's going to be plus or minus a over b. Again, rise over run. So you don't need to necessarily memorize which one is which, because if you draw it and then you just say, okay, it's going to be plus or minus rise over run, which you'll be able to see which one's rise and which one's run on your graph, easy peasy. So rise over 1 times x minus the x value of the center plus the y value of the center. So you can pretty much read the equation off of your graph if you know that, okay, we're doing it in point slope form, where the point is the center and the slope is either going to be a over b or b over a. It's going to depend on if it's the horizontal or the vertical. So hopefully all of that makes sense. That's all of the pieces of our equation, plus how to find C, I should say how to find the foci, and the equations of the asymptotes. Hope that helps, and I will see you in the next video.